The broadcast is now starting. All attendees are in listen-only mode.
Good morning. Thanks for joining Boundary Systems weekly webinar. We're going to wait a few more minutes to let a few other attendees trickle in, and we will get started shortly. Hello again. Thanks for joining Boundary Systems weekly webinar. We're going to get started here in just one more minute. We'll give a few people a little bit more time to join us, and so just hang tight for just another minute. Thanks. Good morning, everyone. It is 11:33 by my clock, so we're going to go ahead and get this webinar going. My name is Nicole Deringer from Boundary Systems, and thank you for joining our weekly webinar series. Although we will be taking a little break for the holidays over the next several weeks, always be sure to check out our website at boundarysys.com for upcoming topics. Today we're joined by our partners at Sigmaxim. Jennifer Sanders and Charles Farah will be presenting today. They are here to present Sigmaxim's automation software, and their presentation is called Rules Perfect. With that, I'm going to turn it right over to Charles to begin. Thank you.
Oh, hi. Good morning, everybody. So we're gonna be presenting this rules perfect automation. We call it automation that work. Hopefully, you're gonna be able to see something that you haven't seen before, as far as using CAD automation, manufacturing automation to accomplish things that you want to accomplish repeatedly. Let me present myself first. So my name is Charles Farah. I'm technical director at Sigmaxim. We are based in Boston. I'm based in Boston, actually. And I've been in Creo Pro Engineer in the past since 1990, basically. So I've been in this world for a long time. The company, Sigmaxim, has been around since 2001. So we're headquartered in the Boston area. We have operation in Europe and Asia. And we're a PTC software partner and service partner. So we are 17 years now. We work very closely with PTC, with Creo, and Windchill to make sure we are able to have software that can keep in touch with the latest releases of Creo, and it always works. So our customer base is global. We have customers over 40 countries now, literally thousands of users of the software. This is nothing new. And as an objective for the company, what we do is design through manufacturing automation, things related to configure to order product, engineer to order product, and custom product automation. So anything related to automating things that happens all the time while you're building a product. So why do companies want automation? Usually what they want to do is trying to build the as sold to order product quickly. So eliminating all this non-value added engineering work that has to happen when somebody orders a product. Your product, you're not inventing anything when somebody orders something. The invention has already happened, the rules are known, and what you need to do is put a bunch of people to accomplish what is it that you want to build. So you want to ensure the deliverables are reliable, no errors, and you want to ensure that you have all these deliverables happening automatically while all the rules for this product are maintained. So that's kind of the overall typical way you're trying to do. And our take on it is that for easier product, simple, small things, there is a lot of things that you can do natively in Creo to do that work. However, as the product get bigger, things at building size, things that are hundreds of thousands of components, natively you cannot do the work without having some tool to help you kind of figure out how to maintain those rules to each other. And I'm going to talk to this concept. So what we look at it is what we actually set out to do is make automation infinitely scalable. And no matter how big the product is, no matter how many rules you have to maintain as you're building it, the system is able to actually gather all these rules and apply them consistently every single time. So from products that are like a boat, which are multiple subsystems that would exist inside, to things that are much more flexible, like you're making basically toolings for bottles and stuff like that. So beside the size of the product, there's also product that require you to have a lot of design flexibility while you build them. So it's not a product where it's totally like a pump. It's pre-engineered ahead of time with multiple variations of what is it that you can change in it, but rather a product that kind of have to fit an environment that you're building. So things like a yacht here, each one of them is a unique product. An architect actually draw what is it that you're trying to build. So how can you automate something that is going to be very different from one point to another, and that's the type of thing. Another thing would be like watches. You're really literally designing watches to be unique from one to another. So what you're trying to do is basically automate the process, the step that's gonna be taking as you build these products. So things like in the medical field, things that are product, industrial type product, they're very different from one to another. However, the process of building them is the same. So we want to automate those things. So for us, in the company, since we've been working in this automation for 17 years, internally we have something like over 20 different what we call implementation practices. They're all automation, but the need of different company about how you implement automation differs. So what we needed internally is to actually, we had to build tools that apply a lot of different environment, but internally we also had to be able to talk to each other. What is it we're trying to do? So rather, I'm not going to talk about 20 different things. There are a lot of nuances in there, but I'm going to take 4 different buckets and talk about them in here and show you some demos. So the very first thing is something what we call configurator-driven automatic build. I'm going to talk about something we call interactive automation, which sounds like an oxymoron. I'm going to talk about something that's dealing with like engineer to order type product, configure to order to engineer to order product automation, which kind of a mix of these two. And the next thing I want to talk about is something we call virtual master model, which is really dealing with very large assemblies and the way we look at large assemblies and how we implement them. So let's start with the first one, which is probably what most everybody think about when they think automation. It's product, what we call configurator-driven automation or automatically built products. Creo, for example, gives you tools like Pro Program, which allow you to pretty much have an overloaded assemblies and allow you to actually turn on and off features and sets and parts and actually create a finalized assembly and part based on it. So this whole concept is what almost everybody that think about automation of a product would think about. And we have different approaches, obviously, to over 17 years, we're really working in this field. So we have different approaches how to work with this stuff. But for us, there is applicability. So the applicability of this whole concept of automating the build of a product is that you have a product that can be fully defined right from the beginning. All the rules could be infinite set of results that will happen based on these rules. And the input could be large, could be complex, whatever, but you can pretty much define everything up front. There is no intermediate user decision that has to take place. Everything can be known up front. All the product exclusivity, dependencies are fully known, so there's no invention in here. And you have a need for to be totally autonomous, to build it totally without having any user interaction in there. So all your engineering and non-engineering staff can go literally enter a bunch of input data and automatically build a product. So products like that would be things like, like couplings, like power control lineups, things that are could be very, very complex, but the way to build them can be defined upfront, and you can build these products. Now, I mentioned Pro Program because anybody who's been in Creo for a long time have seen something that says Pro Program. Maybe you understand what it does, but the idea is that you overload these assemblies and build them. There are gazillion limitations to do those things. Otherwise, we would not be in business building something specific for automation. And mostly the limitation is that you're only turning on and off stuff. So most products do not fit in this environment. And then as this stuff grows in options, it becomes very unmanageable to do. So our approach is to literally be able to apply the rules on the fly and build them. And over the year, we build a bunch of tools to do that. So the very first thing is that with some customers, they need to be able to capture these rules and to build them. So the very first thing that I'm going to show you is what we call SDS Web, which is basically our configurator. It's a web configurator. You go and you sign on, you have an account, and out of this, an administrator would have built what the product rules are. So you have methodologies. In this case, we are picking a bunch of different options. Different options will go into database, crunches data, give you some results back. It can do some math, which we will be doing later. So an administrator went and defined what your products are and what the exclusivity rules are, what the dependencies of different things to each other are, what is it that you're going to present to users in order to capture these parameters. And if you hold on in a little bit, you're going to see Creo. So I know this presentation is for people who are interested in Creo. Once you define these methodologies, a server that's sitting on totally different, in your server room is going to look up and start building the stuff in Creo. So Creo is going to take that data, which is all the rules of how to build that product, and you see assembling what it needs to assemble, creating parts as it needs them, create a drawing as it needs to create that drawing. I'm going to stop this for a second. All of this is happening on a server in the background. Nobody's seeing this, but that will make for a boring demo if I don't show you what's actually happening in the background on that server. It's happening with non-graphic mode because it's a lot faster to build it with non-graphic mode. So it builds whatever it needs to be to build. And then whoever is on that portal, in this account, he sees that there is that configuration, and that configuration has certain deliverables that happen that came in from Creo. And in this case, we kind of sent them that drawing with a bunch of other calculations, and we sent them basically a PDF of the drawing so they can decide whether that's indeed what they want to have. So this is, to us, this whole area where we are crunching product automatically. The rules of how to build these products is known, and we put them together by reading these rules and going in Creo and building the stuff in Creo that we need. Now, so far it's pretty straightforward configuration of product that we've built. Even though here I showed you stuff that's building a new object, not just putting objects together. But you can see that it's assembling things together, it's creating some features, making new parts, making some drawings. Configuration also of automatically building product can happen much more in a much more complex environment. So I'm gonna show something else here that is a little bit next step, basically. So what we have is this this packaging kind of environment where we're putting together some pump equipment and all the plumbing of how these things are going to go together. So again, we're going to go into this configurator. We're going to build it. Some of our customers might not need this front end because they have their own ERP system or whatever it is that they have to capture the rules of what and the options of what the customer would want, their customer would want. But here it's going to go then into the server, and the server is going to try to build these things. So the very first thing it's trying to build is looking at what we asked from it to build, and it's going to build it. It's just coming in from this configurator. It's putting together one object at a time. And I will try to stop it a little bit here for a second just to describe something before it continues. In most cases, people can understand a product that you can define it in rules and you can apply these rules. A lot of time we have customers that say, well, my product is too complex because really the rules does not fully define the product, and I need to kind of look and decide how to solve the situation. It just happened that the human brain does not work the same way a computer works, where you have basically decision path. The human brain is the best pattern recognition tool that exists in nature, and it kind of works with multi-threads, thousands of them happening at the same time, and you recognize the pattern and you just apply it. However, you can actually map it so it can see things and apply them more systematically. So in this case, we can see that geometrically, the rules told it that we're trying to do something that can't be done. And usually what's happening is the decision tree basically will take on and just go and solve the problem based on the methodology that a user would use to solve the problem, like in this case, starting a different path. And if I'm to slow down a little bit, you can see here that as we added some equipment in here, the system decides that we have to recursively go back and fix what has happened before. It's literally the way you would think about it, but you have to map it a little bit of a more systematic way in order for the system to understand it, to actually execute on it. So we call this geometry-based decision-making, which kind of applies on top of this auto-build, which allows us now to actually apply these auto-build processes to a much broader set of products that usually you wouldn't think that they wouldn't apply. So that's the very first type of product that I want to talk about, which is this configuration-driven automatic build of products. But not all of these not all companies are a good fit for a product like that, for automation like that. With some people, you can't actually derive a product totally by rules. And usually you have to have some human deciding of making these decision-making. So how can we automate an environment like that? We call this interactive automation, which sounds like an oxymoron, interactive and automation. However, basically what we're doing is we're looking at the process of building a product and streamlining it, making it faster, because the product cannot be fully defined. So we need to have some user input in order to build that product. Not all options and rules and dependencies are actually going to be known. So what can we do? Or what kind of automation can we do? We can take the commonality, the things that happens all the time, and build them up with these micro or mini automation that would be reused over and over again in different order in order to execute what we want to execute. So I'm going to start, for a couple of examples. So let's look at the first example, which is like tooling, which is fixture. If you think about it, a fixture is going to look very different every single time. So somebody who build tools and build fixtures will look very different every single time. However, what it is a combination of things that happens every single time in different order. So we don't know what the fixture at the end is going to look like, but we know that we're trying to build a certain, in this case, milling fixture or a assembly fixture or something like that. And then I can automatically basically build an assembly structure out of this part that automatically have what I need. I can then go and say, I want a clamp, I want the center clamp, I want to pick a certain center clamp. It's going to go into windshield, bring that center clamp, assemble it, go find the proper screw that has to happen in here, go into the plate, make the proper hole. So what we've done here is multiple steps and made them one. Here's a handle clamp, same thing. I want to click that handle clamp. I want it right here. It's going to go and bring it up. It's going to tell me you want it somewhere else. Yes, here you go. And every time it's doing it, it's assembling it, bringing the proper shim stack based on how high it's ended up here. We put it on different heights, so you see different shim stack, making the proper holes where they're supposed to be, bringing the proper bolt, screw it in the right place. So multiple steps are happening, and they all mesh up together. So it's not just speed, it's the potential of making errors. Here's, I want an alignment pin, so where do I want it? Right here. Again, it's going to create the right hole with the right clearances, etc. So we continue. This process automation is a combination of multiple tools that will happen every single time the way you would use them. And you would use them onto different assembly with different product interchangeably. And you can still use interactive Creo to do whatever doesn't fit into the process. It's one odd place where it's going to happen. So However, the things that happen kind of a lot, you map them into these automation tools and you kind of start using. So as you see, so the goal here is not to reduce something into, you know, few seconds. It's reducing it maybe into an hour's work versus a day's work or 2 days work. And here you go, I'm going to go and create the drawing. So creating the drawing, you know, I want to make it just with dimension. I want to ordinate. I want to make a bill of material. I want to wait a whole chart, etc. So this is what we call interactive process automation. It's just looking at step by step and building it. Now here I used it for fixturing, which is tooling. I can also use it in product design. We have a lot of people, for example, that use furniture, wood design. This example comes from actually that boat that you saw you saw before. So we have customers that do yachts. And for a yacht, literally, people go in and an architect comes every single yacht, and here you go. Here's what it's supposed to be, the interior of the yacht. So what we want to do is give a system that's going to take something very simple design and auto-build the assembly from it by just picking at these surfaces and building them. Now we're going to go to all the wood profiles and swap them. Here's where we want to put them in. We're going to provide tools of how to put the wood together. So in this case, there are a bunch of different ways how you would finger join these pieces of wood together. So what we want to do is give you all the options that you're allowed to do, and quickly, here you go. I want to assemble it in so it create the features properly in the right location with the right hardware and the right clearances that can be manufacturable. I want to move the same thing to the other side, so automatically it will copy this whole methodology to the other side. I want to put these two together, and I want to use a bunch of screws to do them. So you have also methodologies of how many you need and where you need to have them, and automatically assemble them, make the holes, put the hardware, right clearances, etc. Maybe we look at this end and we realize, yeah, this is not really manufacturable. So I want to automatically basically put up a proper profile so the router can go in and be able to make something where we can actually assemble the other pieces to it. So it puts it in. And another things we can see that somebody decide to have a drawer here. So why draw the whole drawer? I have a piece of wood here that's going to be the drawer. So automatically we're going to turn it into a drawer. So we know how a drawer is going to happen. The same thing with a door. Here's a door. So I'm going to place all the proper hardware in the proper location with the proper clearances. We know how much wood thickness needs to happen between whatever hole we drill and the edge, so we can shim it out and make sure it happens pretty much automatically. So we're taking things that takes a long time to deal with and making them, you know, pretty fast. Again, here's another piece of hardware. So we have this piece of hardware we use all the time. So rather than creating the feature here, feature there, assembling, bringing the right hardware, automatically I want to bring the mini lock with its retaining side on the other side, automatically assemble it. So again, we have different type of finishes. So I want to apply the finishes with the veneer on them. So I won't have to do them in one shot. And once that is done, I want to machine all of that stuff. So these things happen on routers. We have pieces of wood. So what we're going to do is nest them based on the type of wood that's going to happen. So I'm just going to go in there. And this is different design, same type of thing, same type of tool, actually. And what we're going to do is literally classify the parts based on their material, build them up. They're going to end up being 5 different sheets with different material maybe. And from there, we're going to basically route them. So it goes on a wood router and create all the tools as needed. So you can see here the tool path moving for the router and building it. So these things is what we call interactive automation. It's not the click button, everything happen in one shot. It's literally you decide what's going to happen, you decide what you're going to choose, but the things that are painful, that really cause most of the errors that happens is removed from the user. And on, you know, tons of examples of where how these things would work. So this is kind of the second crux of what we call automation, this interactive automation. The third one is more going to be conceptual. I'm going to explain because what it is if you think about what an engineer-to-order product or a custom version of one of these products is, it's an engineer-to-product, an ETO product is usually maybe 90% of it is a CTO product. It just had these extra 10% that has to be applied to it. And even when you look at custom, it's probably another 10% of that is totally custom in there. So the idea is that rather than what we want to do, a large portion of it can be defined, so we can pretty much build it automatically. But even this 10% that is ETO, there is this commonality that happens a lot with what makes it ETO. So what we want to do is use this interactive mode to actually build those extra 10%, or at least 90% of that extra percent. So what I showed you, the two examples that I showed you, combine the two together. And basically what you have is this, how we deal with ETO product and how we deal with custom products. So ETO and custom products is basically the combination of the two. We're going to auto build, and then we're going to go into this interactive tool. It's going to be automatically prompted. Most of the build is happening in here, and somebody's notified with the extra stuff that they have to do, and they just go and do them. Now, the last point I want to talk about here is how we build large product automation, because that on itself is unique. We need to build these large assemblies. We need to automate them, and it needs to be manageable. So I'm going to give you an example. Cooling tower, something like that has probably almost 1 million components. So multi-story high. So how do you build stuff like that? If just to load it, can't load it in Creo. So what you do is you build it from bottom up. And the idea is now is that you can manage it by, rather than turning on and off stuff, which is typically you would think about in automation when you use, not just in Creo, any CAD system, because these systems are designed with what's mostly people can see. So what we want to do is build on the fly, and you notice once we built one of those, it's no longer in memory. So we have simplified the reps on the fly, it turns off everything else, and now we're dealing only with this portion of the design, and we're doing all the analysis of how to deal with it until we build all of them. And now we're going to go to the other side and only have the parts of what we need in memory as we are deciding of how to strengthen it, how to build those things, following these rules. And you see these things happening pretty much on the fly. So we're not turning on and off stuff. We are bringing component, creating new component, and following the rules of how you want to create them. Okay, and as we continue with this product, it might take a day for something like a tower, actually could be more, at the end generating 15,000 drawings, but it's happening all on the fly. So little by little you manage basically what is loaded up, and as it continues, you just turn off everything else, and you only need the outside basically skeleton in order to build the sheathing, and from there you have the equipment, so you don't need the sheathing. You might not need any of the structure if you want to. So you simplify the problem by just looking at it one piece at a time. Okay, so how do we do that? Okay, traditionally, people, what they do, and you think about it like in terms of programs or in terms of overloaded assemblies of any sort, is something that many people call a master model. So they build something and they kind of put everything on top of everything else. And you can quickly see that this becomes absolutely unmanageable as the options grow. And usually over the years, these options grow. Now, here we have it kind of represented in this mess here, just to represent how typically people build this stuff. You can see there's a lot of stuff on top of each other with different variations of where it's going to be, a lot of features that are on top of each other. And typically what people will do is will take this master model and whittle it down by just turning off what they don't need in order to get your 100%. So we think this is kind of unmanageable. Actually, it's proven to be unmanageable. It's very hard to manage, and also it's very long. In order to build that, you're going to bring in 1,000 times more stuff from your from Windchill, for example, in order just to arrive at what you want. Plus, you have such a massive amount of data that you probably can't open them. Now, what we have proven over the year that's way more manageable is to build up. And here I'm going to say it from 0%. Practically, you never build from 0%, but you could. You're building from, most of the time, from something that might be 40% baseline that you will always use, and you build up to it. So the virtual master model for us is a way to represent all of this mess in a very simple way by taking all of this information of how things kind of map to each other and putting them into an external information repository. Windchill still contain all your CAD data. So Windchill is going to contain the CAD data. Windchill is going to contain all the configuration data of how things are going to come together. But the way, physically the way stuff are built are not in the Creo master model, but rather in an information repository that tells it where it is. That opens up a lot of opportunity for us, where now we can not just build it faster and manage it much easier, but as we're building it, I can gather data about cost and make decisions on that. I can get data about availability. Maybe you have a lead time based on maybe what country is going to be built in, and build different options as we're building it. Maybe what plant will decide also on different options. Supplier, any regulatory stuff from one country to another might swap some components maybe. So it opens up a whole load of worlds for us as far as what we are building and how we're building it. But really, the biggest thing is that it allows it to be manageable. Now, as we implement this thing, we don't ask users to throw what they've done over many years, even if they tried, have a bunch of them that are actually mapping together and working. So we have a methodology of virtualizing that stuff, which is going to basically take this master model, this mess of thing that they have on their hand, and it's becoming harder and harder to manage, and making sense of it by basically distilling this information into that repository of information, that virtual master model info, and the rest of the info stays in Windchill. So a simple reconciling of what that data into a more manageable data structure. After that, the day-to-day build of building a variant, whether this information for the variant coming from Windchill options variant, from our configurator, from some other configurator that might exist, from ERP system that you might have, on the fly, basically, we're going to take the information from Windchill and auto-build it. The same way you see some of these demos building these things in there, we're basically making sense of how that information load together and building it up. So far, to wrap up this presentation, what I hope to have shown you is multiple different ways of thinking of automation in Creo, and opening up different ways of implementing these automation in a company based on what the company does. You know, to summarize, is basically automatic build product that can be automatically built based on rules and making deliverables automatically. Product where you need users to interactively make decisions on them, but we can crunch that time and the potential for error down to a minimum possibility. Product that is kind of span both worlds and how to deal with these large assemblies. That kind of conclude my presentation. We will have time for questions, so we can open it up.
Any questions? I know a lot of you are already familiar with Sigmaxim. Any comments, anything like that? Anyone? Bueller? Oh, wait, I think I see a question. How much, and this is from Adam, and he wants to know how much programming knowledge do you need?
Yeah, so a typical user that our typical user is somebody who knows Creo, not somebody who knows programming. So there are scripts, there are logic that has to be mapped out in there. Usually, we have a 3-day training course that we take it to a 5-day, where we start building the automation with the customer. So we have a 1-week training course that goes in it. We don't expect whoever is using this to be a programmer. We expect them to be a good Creo user, and that's a much harder. We need them to understand Creo, and not really programming, because the programming is really minimal. Understanding an if, which is a branch or something that loops and does stuff multiple times, is very minimal. Understanding Creo is much harder.
Right. You would be able to read through one of these scripts and know exactly what the application is doing. We call it a Creo English or Kringlish.
Yeah. Yeah.
So we have another question from Fernando. Can this work with existing ERP configurators like Oracle or
Yes.
Expert Logics, for example?
Expert Logics, I do not know. Oracle, SAP, there's a bunch of them. So what I showed you in the beginning, this web configurator that we've built, this is a more recent for us, probably the last 7 years or so. The company started actually working with other people's configurators, and home built and internal built. So there's a gazillion ways for us to gather the input and build with it. We only built our own web configuration tool because we had customers who don't have anything, and they need something to quickly and easily kind of define an input. But that's not necessary. Really the core of the product is the building in Creo for us.
So we can pick up and or even push out information to any ERP type system. And yes, we've done tons of work, like Charles said, with other people's configurators.
Yeah, I would say even probably most of our customers don't have our configurator by far. Most of our customers have somebody else's configurator or even homegrown configurators that they would use.
I do want to make a point that this is something that, most companies have a hybrid approach to working with us, where they do, we start out doing applications for them. When we do them, they're totally open for you to look at, to make changes to. Companies end up taking the training session and tend to take it on from there and build their own applications.
Yeah, correct. This stuff is not very difficult to. This stuff is not very difficult to learn. We need you need people who are good in Creo so they can architect stuff in Creo. But even if we end up architecting a certain automation, they don't even need to be that strong in Creo. They still need to understand Creo, because the command that it works with is a Creo command. It's like create simplified rep. It's create simprep. So when you see create simplified rep, you have to know what it means. You have to know that you really need to create a simplified rep at this moment, and that's what you're trying to do. So that's why the user is really a Creo user.
And we had another excellent question from Joe. Does this software require to interface with an ERP system or configurators? Because configurators take a lot of upfront planning to determine accurate rules that do not allow interference issues.
Yeah.
Excellent question, Joe. Absolutely not needed.
Yeah, it's not needed. So a lot of products really maybe people are trying to get some input in engineering to crunch a bunch of stuff all the time. And in that case, really, you don't need a configurator. It's a software itself can have there's an interactive mode that we can pull up a GUI and you enter a bunch of stuff and it works. The other stuff is it might, the word configurator might mean a lot of rules that are built inside that web front end. And it's not necessary. It could be that all you're trying to do is gather a bunch of input and just shove it to the system for the system to go and crunch it. And that's perfectly fine.
I would like to add, Charles, that we do see rules inside of a configurator, product rules. You can buy this with that or this with that. Yeah. We see the rules inside of, right. We see the rules inside of SmartAssembly as design rules, and they tell you how to build your product. So we do see a differentiation between that, Joe. But also, I wanted to say, it isn't all about configuration. You can build up your product in something that is totally engineered to order, so you're not getting all the way to the end. Maybe you're only building it up 90%. You can work with it as regular native Creo at that point. Yep. There's nothing suppressed or anything. Yep. Really good questions, though.
Yeah, pretty good questions. Yeah, Jennifer's point about about what kind of a rule. I think that brings up a point. Is a lot of time what we see is people are trying to build gazillion rules inside their their configurator, because they're trying to actually figure out things that should be pretty easy to figure out geometrically, and you're trying to break them down into, if I do this option, I don't have the other options and whatever, and you're trying to have, like, the decision tree becomes so immense that you have gazillion rules inside your configurator. We see that a lot, and to us it says, is that necessary? No. A lot of time, what you want to have rules there to prevent users from selecting options that shouldn't go together. But after that, a lot of it that you see isn't really related to the user. You're trying to get them to pick things that can't be built, and that should be deferred to the engine in the background that will decide how and where to build. Almost like what you saw with this pipe thing, where as we put equipment, things don't work anymore, so you have to come up with the next solution in order to make something manufacturable. So you can think that you can. I see a lot of cases where configurator rules can be way simplified if you say the user has no business even dealing with that. This is for us to deal with how we build it. So you remove all of those things. You only give them the options that they care about, and the manufacturability of that product should be taken up by the server. It's a lot easier to do it that way.
Mm-hmm. And I think it leads to another point is, in the past, everybody looked at automation as having to know every single outcome before doing it. And now we've kind of turned it around. It's more in a step-by-step, where do you begin, and build from there in a modular type approach.
Okay. Good.
Keep the great questions coming. Anyone else? All right. Anybody has any more questions, they can get in touch with Boundary Systems. And we definitely would like to thank you for your time.
Yeah, thank you everybody for your time. Hopefully that was an interesting presentation and you got something out of it. It ramp up some different way of thinking about solving problems. Thank you very much.